Welcome back. In this class, we will learn about the various type of variables in C++ based on their function. As a first one, we have global variable. By the definition, if a variable is defined outside all functions means the main function as well as the user-defined function, it is called as a global variable. The scope of a global variable is the all program. This means that it can be used and changed at any part of the program after its declaration. So a variable, suppose x is defined as a global variable, means it is accessible to all the functions inside the program. So any editing done at any function will change the value of the corresponding variable. Likewise, its life ends only when the program ends. We'll see a small problem. This is a C++ program to illustrate. This won't be read by the compiler. Use of global variables won't be read by the compiler. Okay, we have the include input output stream using namespace std. Global variable, compiler won't read this one. Integer global 5. We are defining our global is equal to 5 for the entire program. Global variable accessed from not readable within the function. Okay, void display. Then inside we have cout global and line. So one thing not here is that this is the user defined function and this is the main function. So when the compiler reads after the first line, second line, the control will come to the integer main. Okay, so integer main display. From here, the control will after executing this line and this line, we have the integer main display. So from here, the control will jump to here display. So changing value of global variable from the main function. Okay, let's see. So in this value display, the value will go to here cout global. Cout global. So after executing this line, when it comes to here, the value of global initially is 5. So this 5 will be printed as the value. Okay, so the return value will come back to this point. Then it will keep on executing the statements. Then we are defining global equal to 10. Then again display. Then again from here the control will go to the user defined function with the value of global as 10. So display global. So then next time as the uh, variable is defined as a global variable, the value gets changed to 10. Is very clear. That means the value will change if it is edited in any of the or it is changed in any of the functions. It's called as the global variable. It's a local variable. It's very clear now. It is a variable which is used only in a small function, not like for an entire program. A variable defined inside a function body, a variable defined inside a function defined it's inside the function body between braces is called as a local variable or automatic variable. Its scope is only limited to the function where it is defined. In simple terms, local variable exists and can be accessed only within the function. It can be the main function or it can be the user defined sub functions. The life of a local variable ends or destroyed when the function exists. So it will be we'll make it clear by a problem. I'll use the pointer and sorry. This won't be read by the compiler. This won't be read by the compiler. First executed, second one executed. So this is the user defined function from here to here, from here to here, from here to this point. Directly after this one, the control will come to integer main, curly bracket, cout age is. So this will be printed as such, and then function. So the function is not known to this program. So this will identify the corresponding user defined function. Uh, this variable is local to the function. This won't be read by the compiler. Integer age equal to 15. So one thing to note is that we are not defining any variable outside this function like before. So this age is defined only inside this user defined function. So age to 18, cout age. So this value age will come here. So the output will be age is, then as there is no next line option, directly this value 18 is coming to the same line. If there was next line like backslash n or n line is there, age is semicolon, 18 will be on the second line. I think it's clear this flow of commands. Next we have the static local variable. The keyword static is used for specifying a static variable. For example, in the integer main, on the main program, we're defining not as a float a, but with a prefix of static. So what change this make? Let's see that. A static local variable exists only inside a function where it is declared, similar to a local variable. But its lifetime starts when the function is called and ends only when the program ends. This is the main difference. It's once again, its lifetime starts when the function is called and ends only when the program ends. The main difference between the local variable and static variable is that the value of the static variable persists the end of the program. Let's see the difference by a problem. Okay, there is output also. Let's go through this to demonstrate the static local variable. Hash include input output string using namespace std void test. So this is from here to this point is the user defined function. Writing user defined function, and this is the main function. So after executing statement 1 and statement 2, the control will come to integer main. Integer main, this one test is a user defined function. This will hand over the control to the user defined function. So test bracket, okay, with the semicolon. So void test variable is static variable. Okay, we are defining static integer variable equal to 0 plus plus variable. So that means first I have static integer variable equal to 0. Okay, so initially the value here is 0. There is a plus plus variable. So before executing this loop, so that means at the next statement, the value of 0 changed to 0 plus 1. So here the value of variable will be 1. Very clear. So this will be returned back to the this command test. Okay. So the value will be printed as 1. Then again test is coming. So the control will again go to here. So the thing to note is that as it is defined as static, the variable value changed to 1. Okay, so after executing the second statement, it is plus plus 1 equal to 2. So the next value will be 2 on returning to the second test statement. So that's what I'm telling, that's what the difference of the static local variable is. That is, the value will be keep on adding or changing, and its uses for lifetime, or like for the till the end of the program, the value can be kept changing. So it's a comparison between the static and the auto variables. Okay, yeah. Uh, Automatic variable. It means the local variable. By default, all local variables are automatic local variable. Hence, auto can be used to declare an automatic variable, but it's not required. It's understood by the compiler. Static keyword must be used to declare a static variable which duration or lifetime uh, it has a lifespan. Okay. So automatic variable scope is always local to that function in which they are declared. That is, automatic variable can be accessible within the same block. In the case of static variable, scope is also local to that function in which they are declared. That is, static variable can be accessible within the same block. Then automatic variables lifetime is local. Automatic variables exit till the function execution time. When the program's execution leaves the function execution, variables are destroyed. That means once the program jumps out of the local function, the value is lost. In the case of static variable, the value is keep on adding or changing till the end of the program, which we have seen before. Automatic variables can create a new each time when the program execution enters into the function and destroys that values when it leaves. But in the case of static variable, as we see, when the program execution enters in the function first time, destroys when the program execution finishes. They do not again. So that value will be keep on changing till the end of the program. Next, we have the register variable. This is not that much important in the new C++ version, but as a theory, the register variables are similar to automatic variables and exist inside a particular function. It is supposed to be faster than the local variables. If a program encounters a register variable, suppose we're defining a variable as register, it stores the variable in processes register rather than the memory if available. So the value of that variable will be stored in the processes register than in the memory. So this makes it easy to call back the values. I think it's very clear to you. That means normally all the variable values will be stored inside the memory of the CPU. But here the value is directly stored in the process register so that it can be easily called out so that we can run the program faster. This makes it faster than the local variable. However, this keyword is deprecated because we have the advanced functions and advanced computers so that this time lag is not that much serious. The register keyword is a request to the compiler that the specified variable is to be stored in a register of the processor instead of the memory as the way to gain speed, mostly because it's heavily used, because we are repeatedly using this variable and the compiler may ignore the request based on the case. We will stop for this class.